right. So adding, subtracting, multiplying matrices. We're also going to talk about a little bit on how to solve some of these. We'll do more solving towards the end. So we're going to be looking at adding, subtracting, multiplying. Notice how dividing is not on there. You cannot divide a matrix. We are going to be looking at the inverse and the determinant. That will be on Thursday. And then we'll also look at partial fraction decomposition. Okay. That's more so a request from the calculus teachers to make sure that is, because that's going to be something you'll need going into that world. That one's pretty cool how it works out. You remember rational functions where you could have like x plus 2 over x plus 3, and then you would add it with another one like that. You'd have to get a common denominator and all that stuff or whatever. Well, I'm going to give you the answer of that, and partial fraction decomposition breaks it into those two fractions again. So it's kind of cool how that works. And it's like you use matrices to make it happen. So like I said, we'll throw that in at the end of this. And then we'll be done. And we'll have a quiz at the end. So the hardest part about these problems is that they're so easy. And I'm not saying that just to say that. It's literally plugging them in your calculator. And human error happens a lot, okay? You have little to no work to show. So do not take a quiz, test, or whatever and just submit it. I would at least plug these in once or twice because you can forget a negative. Instead of plugging in a 12, you plug in just a 1, all the things, okay? So we are looking at the dimensions of a matrix, okay? You are always going to write your rows by your columns, okay? I just have my Reese cups and my remote control on there because that helps you remember which one comes first, okay? Your rows and then your columns. So this is that box of floating numbers you have possibly seen on the ACT. This is a matrix. So looking at this particular example, how many rows do we have? 4. And then how many columns do we have? 3. Okay, so this is a 4 by 3. Think about the columns that hold up a house. So there's the ones that go in vertically and then going down a row just horizontally. Okay.
Reese's are really good.
Huh?
I really like Reese's.
I do too.
Just a combo is oldest time. Chocolate and
All right. So we're going to go from a systems of equations and we're going to make it into a matrix. Okay. So remember systems of equations when you were in algebra 1 and algebra 2 and you had to solve for 2 equations, 2 unknowns. You had to do substitution, you had to do elimination, all the yucky stuff. Okay. Graphing was the other one, and you found where they intersected. Well, now we're looking at 3 equations and 3 unknowns. This is totally doable by hand. I'm going to make you do it with a calculator, sorry. Okay. So we got to know how to take an equation and turn it into a matrix, and then we got to also know how to plug that in the calculator as we go from there. Okay, so the key is to make sure that you keep all of your X's in the same column and all of your Y's in the same column, all of your Z's and all of your solutions. If you do not have a representative of that coefficient, then you need to put 0. So on the last line, we only have an x, we don't have a y, we don't have a z, but we do have an answer. Okay, so all I did was take all of my numbers, my coefficients, numbers in front of the variables, and I wrote them down.
And then you have to like just plug it into the calculator normally, like with the matrix, right?
Yeah, I'm going to go through actually how to solve these. We won't solve them until technically a couple days from now, but I'm still going to show y'all how to do it.
Don't you feel like a conversion or something? It was something in your phone.
Also, with matrices, the more you do of them, the easier it'll be because they'll become muscle memory. So the first one, if you didn't do this in Algebra 2, the first couple of problems, you might be like, there are a lot of steps that goes into just plugging this in the calculator. But once you start doing it more often, then it's just, you go for it. Okay? So go ahead and get out your calculator. And those of you that are listening to the recording, I'm going to do my best to bring the screenshots over. I know you can't see my calculator right now. All right, so step 1, we go to second matrix, which is that little -1. It does not matter if you have a matrix plugged into A, B, C, D, E, F, G. It does not matter. Okay? You're just going to override it anyways. Also, those of you in here right now, if you see what you can't, but red is always the button that I've pressed last. So if you're like, where did she get that? That's right there. Okay. Go over to edit. And you're going to leave it on matrix A because it's easier to just keep overriding matrix A because when you start adding things together. So press enter. And what are our dimensions of this matrix? How many rows do we have? Okay, so we have a 3 by 4. So you're going to press a 3, enter, 4, enter. And the great thing is if your calculator does not form the same look of your matrix, then you did the wrong dimensions. Okay, so now let's enter in our numbers.
This one might be a 4 by 4. I can't remember. Is there another one?
Do what now? Takes me 10 times longer to type these in because I have to do each number that way. So the hardest part again is plugging all of this in. And you're like, typing in numbers is the hardest thing? Yes, because it's where the errors happen. Okay? Do what?
How big do these problems get? Like, how many rows and columns do you have?
For our world, I think it's still just going to be 3 by 4s because it's 3 equations, 3 unknowns, and you're always going to have a solutions column. But they can get bigger for sure. All right, so go to second quit. Go back into matrix. So the math version of this is we are going to find the row reduced echelon form. That's the math version, okay? The easy way to remember for a test is what my students used to call the double ref, okay? So go over to math and scroll down to, you'll see an REF and then you'll see an RREF. Okay? So double ref. That's the row reduced echelon form. So we're pressing enter. And then go back into matrix and choose matrix A. And that's on that first screen. So you're just going to press enter. You don't have to close the parentheses. It's go to second matrix, and that first screen is basically saying pull that matrix for me. Okay, so ideally we would want to have what's called the identity matrix here. Okay, what the identity matrix means is we would want to have a diagonal set of ones and zeros that fill in the holes from there. Okay, and then we would have our solutions at the last column. So that's ideal. In this particular case, we don't have a diagonal set of ones, and we've got a -1 in the place of where a 0 should be. So that's the two things that are not what they're supposed to be. So in this particular case, this one would be no solution. Okay?
The whole thing,
Do it.
the whole problem.
Uh-huh. We could solve for x, but then from there we wouldn't be able to solve for y and z.
So like if you did it like normally, it would just come out to like a fraction or something. That's why I can't figure.
No, it would just be not possible or something like you would lose. When you would actually solve it out, something would happen where like you would get like 2 = 0 or something like that, and there's no variables left.
I don't remember the R ref thing. Is there another way to do this in the calculator?
Not in the calculator.
We should have did this. Oh, we did this. We did do this part.
If you do think of if you did it a different way, let me know. I've never known it to be another way.
I don't know. My brain's not that smart.
Okay, so that one's no solution. Let's try number 2.
I kind of like solving these like algebraically.
You do like solving them algebraically?
Yeah, I thought it was kind of fun.
It's a lot of work.
Yeah, it was like.
Doing elimination with 2 of them and then using that to then substitution, like all that. Yeah.
I like systems.
Yeah. It's easier for me to plug these in the calculator and use the computer. So if you're going through doing a bunch of these, remember you can always do second enter, and it brings back up exactly what you did. But if you're wanting to get in the habit of figuring out where double ref is, all that stuff, then I would just keep doing that. All right. Okay, so when you plug this in, we end up with our identity matrix with our last column being 0, 5, and -2. If you do not get that, that means double check, go back and make sure you didn't put a negative in where there wasn't supposed to be a negative, or you missed a negative, or anything of that nature. So this is literally saying, this is my X column, this is my Y column, this is my Z column, and these are my answers. So this is saying X equals 0, Y equals 5, and Z equals -2. Okay, so it has solved the entire systems of equations for you. Okay. Any questions on how to plug this in? All right. So adding and subtracting. So adding and subtracting, you have to have the same dimensions the whole way through, okay? You cannot add a 3x4 with a 2x3. Okay, you have to add a 2x2 with a 2x2, a 3x3 with a 3x3, and so on, okay? The reason for that being is you have to be able to match up each position and adding them together. So if you had to do this by hand, I would just simply add 0 and -4. -5 plus -5. 6 plus 0. And 5 plus a -3. Okay? That's why they have to be the same dimensions. But I know those of you out there that still multiply 3 times 1, just to make sure it's still 3. Y'all are out there. You can still plug this in the calculator as well. So go ahead and type in this first matrix here is your matrix A, and then your second matrix here is your matrix B.
So is this the type of stuff that would like be on the challenge exam? These kind of matrices?
I think you'll see, well, again, it's changed. What used to be on there is like one of the problems that we'll do here shortly, where you're solving. So we're typing this first one in is our matrix A, and this one in is our matrix B. So once you have that in, you are literally going to go back into matrix in your calculator, and you're going to choose matrix A that you typed the first one into, and then you're going to do a plus sign, and then you're going to do matrix B. Mine are not typed into the calculator up there, so it'd give me an error, but on my calculator here, I did it. Okay, and you should get the same exact answer that we got over here, -4, -10, 6, and 2.
So is the second one like no solution? Or do you have to like...
Right. I'll tell you what to put. All right, so the next one, if we look at our dimensions here, it's a 1 by 2. Whoops. And a 3 by 2. Those are not the same dimensions. So we would put a dimension mismatch. Now, or not possible, either or, but just for fun, and it's also another way to practice plugging these things in. Go ahead and plug the first one in as matrix A and the second one in as your matrix B. Just in case you're in the middle of a test and you're like, wait, I can't remember, with adding and subtracting, is it the dimensions that have to match or is it this? So you can always plug it in.
Isn't this your kid's first Christmas?
It is.
Excited for that?
I am. He saw his first like lit Christmas tree, and of course it was my mom's, and it was
Big eyes.
it was a lot. She does her Christmas trees for her grandkids, like tinsel and flashing like colored lights and all the things. And he was just like, whoa, like overstimulated.
That's pretty cool.
But yeah, it's nice when I can go and buy his Christmas presents and put it right next to him.
Yeah, well,
He has no idea.
that's cool.
Could probably go ahead and unpackage it and would have no idea. But yeah, it'll be fun. All right, so for example, I just did A plus B with two matrices that have nothing to do with each other, but this is kind of the same situation you would run into for the second one. There it is, dimension mismatch. So again, you're not able to do that. All right, so your calculator, if you go back through and you're checking all your work, your calculator will make sure you remember that the dimensions have to match. Subtraction, same exact thing, except you do a minus B. And then, of course, if you're subtracting by hand, just be careful with that negative. Sometimes it's easier to go ahead and change the second matrix, all the signs, and add them together, but it's up to you and your preference. Okay? Multiplication. Like I said, subtraction is the same. Multiplication, you don't have to have the same dimensions. What you do have to have are the same inside dimensions. It's weird to say. This is a 2 by 2, and this is a 2 by 1. These numbers have to be the same. Okay? This is not like, oh, we just multiply the two pieces together. Okay? This is a little bit more in depth. You multiply certain things together, add, subtract, all the things. Okay? So with these particular examples, it's easier just to go ahead and plug them in the calculator. You could still do matrix A times matrix B. It will still give you an error if it's not allowed to do that. But, so these have to match down here. If those match, the 2 on the end is going to be your dimensions of your answer. Just kind of cool how that works out. Okay? Let's go ahead and try both of those. Okay, so the first one we should have gotten negative 11, 14. When you plug in the second one, if you did, again, like I said, just getting that practice plugging things in. This is a 1 by 4, and this is a 2 by 2, and the 4 and 2 don't match. But again, like I said, knowing y'all on tests and quizzes and stuff like that, you want that reassurance. Did I just make up that own rule in my head? If you type this in the calculator, you can double check that, okay? All right, any questions so far? Yeah.
So if you can normally in multiplication, the order doesn't matter, why does it matter here?
So that's I'm glad you brought that up. So with matrices, multiplication is not commutative. So we cannot move those around because of those dimensions. It is a certain process to what you actually multiply together. It's not like, oh, we just multiply 2 times 3, and that's 3 times 2. It's more in depth to that than actually just multiplying. So you can't, if you take the first one, if you already have that in your calculator and you did B times A, it wouldn't work. It's weird how that is, isn't it? But it has to do with the dimensions, because you're going from a 2 by 2 times a 2 by 1. And if you did a 1 by, well, in that one, your dimensions would match, but you can't do that. It's kind of like it's weird that you can't divide. But we're going to do our own version of division Thursday. All right. Scalar multiplication. It's as easy as it looks. If we have a number out front of something, what do we normally do with that? Distribute, multiply, all the things, okay? If you need to, in your calculator, actually type this in, you can do 3 or negative 3 and then your matrix A that you plugged in. All right? But this basically means we just multiply that negative 3 all the way through. Scalar is basically just a number, okay? Scalar meaning number. We're just multiplying a matrix by a number.
I did it like B times 3 just to see if I'd get a different answer, and like the negatives are like flipped in some of the numbers.
Huh.
So yeah, I guess you.
Do you do times 3 or negative 3?
I did times 3. That's okay.
Yeah. I was gonna say it should work for a scalar. Okay. So if you just have the number in front, it's basically like distributing. Okay. So these next problems are like what you could potentially see, or what used to be, on the statewide dual credit test. Okay, they had a problem similar to this. All right. Do you need the last slide?
No.
Ah.
That was me going, whatever.
I can go back.
No. Not, I don't, as in looking at that stuff.
Oh.
Whatever.
I thought you were like, I just won't write that down then. Okay, so for this particular one, we're going to treat it as if we're in Algebra 1 again. That big X is a matrix, okay? We are going to find the matrix that fits into this equation. So we're going to treat it as though we're still in Algebra 1. So go ahead and write that down. Okay, so our first step to getting x by itself would be to do what? Add. Okay, so if we add this entire matrix, now if this is an opportunity to show work, please do it. Because again, if we're doing all of this in the calculator and we mess something up, this one we can actually show some work for and get partial credit instead of just numbers.
What if you can't divide by it?
We'll get to that. We'll get creative. All right, so that matrix disappears and we're going to add that one together. So if we can't divide by a -2, what can we do? Multiply by what? -1/2. Which is a scalar, which we're allowed to do. Now, this is silly because you're like, but aren't I technically still just dividing by -2? Yes, you are. But if you were multiplying by a -1/2, we're basically dividing everything by a -2 in our heads. Then in the calculator, we would not be able to do that.
You tell me.
Creative.
Now, the beauty of these problems is that I can plug it back in to check my work, okay? I can make this my matrix A, and then this matrix over here, matrix B, and I could type in -2 times matrix A minus matrix B, and I could check my work that way. So if I made this one A, and this one B, then in the calculator, I could just do -2 times my matrix A minus my matrix B. And then I would get that final solution to check my work. Okay. Again, whatever time you have left, do that to make sure that you didn't plug anything in incorrectly. Okay, try the next one. So if we first subtract over that matrix, we get 27, we get 0, and we are subtracting a negative 9, so we should get 33. And then technically we are dividing by 3, but we're multiplying by 1/3. So we should get our new matrix x of 9, 0, and 11. Okay. You can always plug that in. Our answer in is matrix A, and this one up here is matrix B, and do 3 times matrix A plus B, and you should get that as a solution. All right. Any questions on matrices so far? All right. So, in your